Good morning or good afternoon, everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Rachel Starbuck from the Business Review, and I will be your host. It is our pleasure to have VTT with us today, who will be discussing smart energy integration for future energy system. Today's guest speakers are Dr. Mimu Araksinen, Research Professor, Eco-Efficient Built Environment, Dr. Kari Mäki, Senior Scientist, and Dr. Markku J. Virtanen, Senior Principal Scientist, Program Manager. I'd like to welcome you to our new webinar platform. You'll notice that this webinar is browser-based, so if you disconnect, please click the link that you received via email again to rejoin. In order to ask questions, you can send them in via the Q&A widget at the bottom of your screen, or use the questions box at the top left-hand corner of your screen. We will allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. If you click on the green resource list widget, there are a couple of PDFs to view or download from our speakers. We also have a short survey for you to fill out. This can be found in the red survey widget, and it will also be available at the end of the webinar. We would appreciate if you could complete this. Please use the yellow help widget if you require any assistance. So without further ado, please allow me to welcome Dr. Mimu Araksinen.
Thank you, and good afternoon, everyone, and welcome to our webinar on smart energy integration for future energy system. We have divided our presentation in 3 different parts. First, I will give you a short introduction for the future energy system and low carbon scenarios. Then my colleague, Dr. Mäki, will give you insight of smarter grids. And our third part is given by my colleague, Dr. Markku Virtanen, and he is giving insights to district energy planning and opportunities for ICT-enabled energy services. So first, a few words about future energy systems and low carbon scenarios. So as we all know, we have these global mega trends such as climate change, urbanization, urban sprawl, security issues, demographics and aging society, open markets and digitalization. And these are all the factors why we need to adapt and improve the whole energy system, including also social issues. We use quite a lot in our working scenarios, since those are powerful tools for us to understand how sustainable transition toward low carbon society is possible, and also to understand what kind of technologies are needed and what kind of policies are needed. We have been recently involved in 3 different platforms: ERA, European Energy Research Low Carbon Platform, Nordic Energy Technology Perspective, and now also in Finnish Low Carbon Platform. We just recently published a Low Carbon Finland 2050, where our aim was to reduce Finnish greenhouse gas emissions by 80% by the year 2050. You can read the whole report in the following link. And in that scenario work, so we had 3 different scenarios. Sonni was our first scenario, which was basically business as usual. We had our current industry, our current urban structure, and applied urban sprawl. In Inno scenario, we used a lot of new industrial products, innovative industrial products. The urban structure was really central and really technology oriented. A lot of high technologies was used, and cities were real smart cities. This scenario had the highest shares of wind and solar power, and also the power plants were having high efficiencies. In our third scenario, which was called Onni, the industry was service-oriented. The urban structure was scattered, and we had there many new single-family houses using very efficient technologies. The energy production was decentralized, and this scenario has the lowest share of nuclear power. And in this scenario, the process industry was rather slow. Based on the calculations in these scenarios, so we concluded that it is really possible to have those kind of high reductions in greenhouse gas emissions. And even in the INNO scenario, which was using the smart cities and smart energy technologies, so it was possible to achieve 90% reductions in greenhouse gas emissions. What else we learned from those scenarios was also that the highest reductions are done in energy and industrial sectors, and also that the share of the renewable energy is clearly increasing compared to our current level. In building sector, the energy demand is decreasing clearly by the year 2050. It was decreasing up to 30%. And when we see more closely the final energy consumption in the building sector, so we can see that the electricity is dominating here. So it is higher compared to the heating energy, even in our cold climate. And this is due to electrical appliances and lighting in buildings. So what we can conclude is that the low-carbon society calls for structural changes in the whole economy. This means that we need to implement new technologies, services, and business models, as well as we need to change our ways of living, working, and moving. And also, our future energy networks are changing. We need to combine our central and decentralized energy production. We need new type of energy network management, and we need to combine energy storages and smart energy networks. My colleague, Dr. Kari Mäki, is giving you more insight on these topics.
Okay, so thank you, Mimo. And I hope everyone is still online as we go towards smart grids now. And I will give you some idea about what smart grid means actually, why we need something like smart grids, and then go to some specific aspects, and also tell you what VTT is doing for these things. So our definition of intelligent energy grid is based on the fact that this is an energy system that uses information and communication technologies throughout the system, so that we gather information and we act on it, which means we are monitoring, we are controlling the system on all levels. And we see this to cover electricity, heat, gas, and we see a very central role for the ICT in this sense. And my presentation today will focus more on the electricity side, so-called smart grid. And this picture here is from our national research program, and it gives a quite good overview of what is the transition from the national grid to a smart grid. So we are moving from one-way transfer of power, data, money to a more complex system where everything is networked, everything is moving in different directions. And this is, of course, more complicated to make. So what are the key drivers for smart grids then? Of course, the most obvious one, which is most often mentioned, is that we need to accommodate more renewable energy resources like wind power or increasingly PV panels. And we need to be able to flexibly integrate different things like storage units or electric vehicles. And of course, a smart grid is also an enabler for new businesses. It forms some kind of platform for this. And as I already said, electric mobility, but not only cars, but like train traffic, and so on is one driver as well. And actually, in the Finnish case, I would say providing better reliability and quality of service is maybe the main driver, because there are increasing requirements for better user level reliability and lack of disturbances in the future. And one important thing is also to involve individual users better, and this is quite an important fact as well. So on the next slide we have some typical characteristics for a smart grid. First of all, intelligence is put on different levels of the network, and the network is very widely monitored and controlled. So it means we will have more and more measurements from the grid, and there will be more and more components that we can control. And the key point is in doing this intelligently. A smart grid is always integrated with a good communication system, and it's built on standardized or open interfaces, so that we can use different vendor equipment flexibly. And there will be new stakeholders, there will be totally new roles, there will be potential for new businesses. And altogether, this leads to the fact that interoperability is the main challenge for deploying the smart grids. Then some more focal points I wanted to list here. First of all, we are crossing traditional boundaries. I mean, like transmission, distribution boundaries, or power system communication boundaries, maybe producer, consumer, prosumer roles. Then we have a lot of things that we could control, and we need to do that on correct level, correct timing, and somehow we need to go towards finding overall optimals of the system. There will be huge masses of information, and managing this, and especially finding the most important parts in it is one challenge. And then, as I already said, end user level needs to be involved efficiently. On the next slide, I have a picture from the IEA roadmap. I think this is a good illustration of the role of communication in the smart grids. So currently we are somewhere in the middle, so that we are using communication for distribution management somewhere at the substation level or secondary substation level. But then on the right hand side, in the future, we will take the communication all the way down to the end customers and to the equipment there. And this will be communicated throughout the system. And then something about storages. Actually, a good storage unit is something that we would really need to make a good system in the future. This is somehow more or less the holy grail for building a good system. And in this picture we have different applications, different levels, and they are ranging from power quality improvement to smoothing some variable generation resources, and even to customer level optimization purposes. So this ranges from momentary control to energy optimization. And if we want to put the storages on the scale where we compare storage capacity with the time scale, we can map different technologies, different application areas, and here we have some example of that. Okay, but then I will come to the topic of what VTT is is doing for these topics I presented in the previous slide, and there are some kind of alignments from our side. We are clearly looking at some joint research platforms currently, so that we are wishing to integrate, for instance, power system and communication simulations in the same picture, and this is a very important platform for the future. We also have some techniques for smart meter data processing, like data mining type technologies. We are very much looking at the user level applications there. We are also doing a lot with the electric mobility and storage integration. And then, for instance, for new facilities or research infrastructures, we are looking for standard interfaces such as ISA 61850. And then I have here some examples of that. So first of all, we have been integrating power and communication worlds, so to say, in terms of putting our simulation tools together. And here's one example where we have a microgrid simulation. And well, this picture shows a very simple microgrid type network. But the key point here is that we are bringing some measurements from the model, and on the other hand, we are putting some controls back from our microgrid controller block, and we are now putting these signals through some communication system simulation, so that we can actually get a grip of the impact of communication in this control system, and we can adjust the communication channels so that some of these units, like maybe a central PV unit, is connected with a fiber connection, whereas customer level PV can be a wireless 3G connection or similar. And then we can access things like communication times, latencies, communication errors, and so on. And this is something we have been working, and this is based on our Apros simulation platform, which is used for modeling the power system here. And the picture on this slide shows a simple version of the system we are running. So there is like a control loop and a measurement loop, and both are taken through a communication simulation. And then we have some intelligence we want to test, and we have realistic system models for doing that. Another thing we are doing is we are developing and applying some mathematical methods for data processing and data mining on the side of smart meter data. And with this approach, we can end up in some new kind of customer profiles, or find some interesting behavior among customers. And this will also support better management of the smart grid system. Another thing we are working quite a lot at the moment is demand response, aggregation of different loads, aggregation of different small generation units. And this is utilizing active components like storage load, electric vehicles, and so on. And of course, there are different solutions, different business models, and these can serve market customers, also network, depending on the circumstances. And in this sense, it's very important to understand the local circumstances, like regulation or market structures and so on. So the business models are, of course, different depending on the circumstances. Another example of our some interesting things we have been working with is applying DC DC power in urban areas for city distribution of electricity. And also here we have some different concepts for applying this and regarding where we are using the DC and what is the customer interface and to what kind of level we are bringing the DC actually. And when we are considering some urban areas or smart city grids, this is one option, but it depends on the case actually. I also wanted to highlight our new microgrid test site, which we have developed, and this is focusing on user interfaces, user level applications, and some local energy management issues, for instance. And I think it has quite typical features like small wind power, PV panels, some storage units. Also EV with a controllable charging ports. But then we have a very interesting system where we can control the domestic loads. And in this environment, we are developing some local management things and also user interface like iPad type interfaces. Okay. So to put together what was on the previous slide, I think we are continuously going towards some integrated and a more holistic approach where we are somehow we need to integrate the studies across different levels of power network or electricity network, but we also need to integrate with different energy sectors, like putting together heat and electricity, and we are continuously working on that. And I think Dr. Virtanen will now go on from this and go into more details about this integrated approach. So I will hand over to him now. Thank you.
Thank you, Kari. Ladies and gentlemen, colleagues. My part in this session is focusing on district energy systems in which individual buildings, their end users, are actually in the very core. Another angle in my presentation is to emphasize the importance and opportunities of information and communication technology, sensors and automation technology included, as enabler for energy services to manage increasingly complex energy systems with final goal to fulfill end users' needs and satisfactions. First, I will briefly discuss the evolution that has been and what is going on regarding the development of buildings as systems and their energy use. Secondly, I will emphasize the opportunity of dynamic simulation of district energy systems in planning phase to guarantee and verify the performance of such systems. And then few words of benefits for various stakeholders using dynamic simulation as a tool in their decision-making process. This slide shows the reduction of total energy demand of Finnish new buildings during past years. The main drivers have been first the concern of global energy sources, especially oil, and then afterwards increasingly climate change combat in general. Up to now, it has been enough to reduce the energy demand of buildings through better thermal insulation, heat recovery of ventilation, and other such technologies, but not anymore. In the near future, all new buildings should be near zero energy buildings. This means that buildings not only consume energy, but they also produce energy with renewable energy sources nearly the same amount that they are consumed. The challenge is the mismatch between energy and power demand and renewable energy production on building level. Therefore, the energy system needs to be looked at larger scope. All this development reflects to existing building stock sooner or later. On the other hand, radically new business opportunities for energy and power balancing will arise. This slide, which has been presented earlier today already, shows the dimensions and complexity and opportunity space for new business opportunities as well. Core words are energy storage technically and energy network management operationally. Demand response issue especially in order to balance energy and power demand and production of building, local and national levels in an efficient and optimal way. Looking at energy system on building level and district level, we are not talking about only electricity and heating. Also cooling demand is expected to increase even in Nordic climate. So from prosumers' perspective, we can expect that buildings will both consume and produce electricity, heating and cooling energy and power. Therefore, open two-way networks for all these purposes, electricity, heat and cool supply are foreseen. In case of heating and cooling and Europe, heating is typically needed during winter season and cooling during summer season. That's why there is an energy efficient opportunity to connect and integrate district heating and district cooling systems to serve both functions. So-called low excessive principle, low temperature heating, high temperature cooling, water-based system as heat carrier serves well for that kind of purposes. On the other hand, local district energy solution is always case-specific, depending on multiple factors such as energy and power demand, local renewable energy sources, local waste and surplus energy sources, business models, and therefore backup to large-scale energy infrastructure may be needed. I would say totally energy autonomous districts may be just a dream of building owners or real estate operators. This is the case with electricity and energy and power, especially because the electricity plays an important role in the future energy business. Future development will show what happens. Again, core words are energy storage technically and energy network management operational. This is not actually a rocket science. A sustainable district and economic efficiency can be reached by integrated system optimization using existing technologies, likely. However, collaboration and co-creation between different business disciplines and stakeholders must be there. Now I move to dynamic simulation of complex energy systems. VTT has developed multifunctional software for modeling and dynamic simulation of complex technical processes. Originally, the software was developed for nuclear power plant analysis. Now it covers energy systems more widely, including buildings with their technical systems on one side, and various energy production technologies on other sides, and technologies there between. The basis of physical modeling of components and systems covering transient balance equations of mass, momentum, and energy. In this slide is shown into more depth what kind of features can be taken into account when using Apros Smart City for dynamic simulation to support district energy planning. Just briefly, it is a development and verification tool for complex energy systems planning phase based on verified models and physical phenomena. We believe that Apros Smart City program can be used efficiently in wider contexts as a simulation engine, just like for optimization of integrated energy system solutions as co-creation of various stakeholders together with multi-criteria optimization methods and visualization methods, and also to support operation and management of energy systems together with many sources of information. The present slide refers to ongoing European CITYOPT project that the above mentioned issues are being developed further. Next, I will give a flash to cases where Apros Smart City has been applied. I'm not going into detailed results, just briefly to look at the cases. The first case presented here is a district heating system where solar thermal and ground source heat pump technologies have been integrated. The figure in the middle illustrates the challenge to match heating energy demand and solar thermal production in the district. Another case is for photovoltaics power plant, and the slide just illustrates the scope what Apros model covers in this case. These are solar position and radiation, including weather in general, solar panel and array characteristics, inverters and maximum power point tracking, electrical network and connection to public grid. And the third case is for concentrating solar thermal power simulation, and also the slide illustrates the scope of Apros model covers in this case, which are various heat transfer media from collectors to heat storages and turbines, various evaporation concepts, and various heat storage concepts. In this slide are listed benefits of dynamic simulations on district energy systems development from the viewpoint of different stakeholders. I don't go in detail to that, just to summarize a little bit. The overall benefits are dynamic simulation is a development and a verification tool of complex energy systems at planning phase to support especially finding optimal integrated system configurations at local contexts, and also defining strategies and control algorithms for the operation phase of energy systems for power and energy balancing purposes. Then the last part in my presentation is to look at opportunities for ICT-enabled energy services through some examples. Kari already introduced some examples of using measured data for producing useful information for the management of energy systems. Just to mention, using smart energy metering data to produce information of user profiles. Our world is becoming instrumented and interconnected. ICT is an enabler for intelligent energy management services. We can see the world of global web-based cloud services and local operating centers which are integrated real-time to building automation systems and instrumentation inside buildings, and other information sources like weather forecasting as well. What data will be open for producing information for various services will very much depend on cyber security issues which are not very clear yet. On the other hand, the obtainable data should be processed to useful information to provide intelligent energy management services. Especially this one is the opportunity space for new innovations, new services, and new businesses as well. Coming back to basics. Buildings together with their users have been and will be increasingly active and dynamic part of the future energy system. Demand of users must be fulfilled. Building information modeling together with real-time instrumentation and visualization is an opportunity to provide improved services for the management of building operations and user-driven performances. For example, different colors. With different colors, it can be very easily be illustrated how indoor targets have been reached. The same big building performance view can be obtained also on district level. In case of performance problems, faults can rapidly be detected and location visualized. These were just a few examples of applying building information modeling. Coming even more back to basics, it's important to forecast people's mobility. In other words, the proper indoor environment conditions should be provided there where people are in a specific period of time. And here is an example where data from instrumentation in combination with mathematical modeling of human behavior could be an enabler in matching the demand and production of power and energy more efficiently. Then going to very basics. Academic break now. Human sensation inside buildings is the most important thing when the approach is user-driven, as it should be. Regarding thermal comfort, which is relating to heating and cooling of buildings, totally new knowledge has been gained by VTT for understanding human sensation and surrounding indoor environment. Now we can understand better than before individual aspects influencing the individual human thermal sensation. This new knowledge will change, when the time comes, radically the principles of building systems design and system controls. Together with the fundamental knowledge of human thermal sensation, new designs, building systems and sensor networks, demand-controlled heating and cooling will be enabled, which in turn again will support the goal of optimal power and energy balancing between demand and production. I will now conclude and summarize our presentations. The energy system is becoming more complex and dynamic than ever before, which makes new business opportunities and roles arise. Increased use of renewable energy sources will reduce environmental impacts, but also challenge the optimization of the systems. Matching energy production and demand in a secure and cost-effective way has to be assured. Totally new energy concepts and systems can be used for this. Intelligent interoperability and interactive user-oriented control of systems for energy balancing and energy storage is a prerequisite. ICT, together with smart sensors, smart metering technologies, and efficient communication, will enable integrated, trustworthy, and reliable smart energy systems. But we think at VTT we can offer to serve this paradigm shift process we can help in holistic understanding of energy systems and their interdependencies. We can support development of concepts for sustainable districts. We have competence in simulation of complex energy systems, integrating various technologies on different system levels. We can support the development solutions for applying new communication technologies for smart energy systems, and also provide technologies for managing and processing big energy data masses, and also have solutions for finding the essential from data available. Thank you very much. And now we are ready for constructive questions and public criticism as well. Thank you.
Okay, thank you, Dr. Virtanen. We are now moving on to the question and answers section. Also, thank you to the people who have already sent in your questions. Please continue to submit your questions using the Q&A red widget. We will try and get through as many as we can. Okay, so I'd just like to kick off with the first question. So, could you be more specific about the advantages you consider to have urban distribution nets in CC, as most of the electrical house consumers are based on AC? Do you consider to convert all these appliances on DC?
Okay, thank you. Yes, this is a good question. I will try to answer that. First of all, I think actually most of the home appliance loads are actually DC, I would say, excluding some things like heating, ovens, pumps, things like that. But if we really look at the loads, they are actually DC in many cases. But that's another story. Of course, the customer interface, it surely needs to be some kind of dual AC/DC system where we are providing the customer with both systems, of course. But when we look from the system level, I think there are some clear benefits regarding integration of storages, DC units. For instance, easy transition to island operation and back. And then, of course, easy use of swing structures in city grids, and also some benefits maybe with the transferring large powers in big cities. But then again, I would like to underline here that we are not, so to say, proposing this DC distribution as a solution to all problems, but this is more like one building block for smart city grid in the future. So this is an interesting opportunity, but of course we are looking carefully looking where we could apply this actually. So this is not our solution to all circumstances. But I would also say that if we would start from a clean table now, building some city area with the grid, this would be a good opportunity. And yes, I recall of course the fact that there are a lot of AC loads currently, so this is more like a future inside. Thanks.
Thank you. And the next question is, how do you see the role of electric vehicles and their grid integration in the smart grid context?
Yes, I can continue with this one as well. This is a good question. It's an interesting topic, and currently EVs are often considered like as they would be some kind of movable battery, and there is a lot of discussion about vehicle to grid integration and about using the EV battery in connection with the grid. But I would actually see it more like a good means for doing the demand response, and yes, providing some services for markets or for grids and so on. And I think the peak power management in charging, it will be very important, especially locally when we think about weak distribution grids where there will be a lot of EV charging. And then, on the other hand, aggregating these PVs, it can be very significant on the system-wide level and for the market level as well. Yeah, so this was my overview of this topic. It's an interesting opportunity in the future. Thanks.
Thank you very much. Just to let the audience know, you can still submit your questions. So on to the next one. How do you see the future of connecting district heating and cooling? Are there any practical moves towards that direction already?
I can try to answer to that. I think looking at the big picture, the heating demand actually is decreasing, and we can well see that also the cooling demand will be increasing. So to make better use of heat available, it can be used for cooling purposes as well, using, for example, heat pump technologies. And in Finland, at least I know city energy utilities have that kind of developments and demonstrations already going on. So I really see that it will be a real future opportunity for energy businesses.
Okay, thank you. And how can we get access to Apros Smart City program?
So we are selling licenses for that, and you can always contact us to discuss more details about the license agreement.
Thank you very much. And Dr. Markku, which version of Apros includes smart grid simulation?
We have included it into Apros Smart City version.
Okay, there isn't any more questions. So is there anything else you'd like to comment on? And
Did you ask
one more question has just come through, sorry. Is there leadership within local governments to support a sizable pilot, say in a new development location and interconnected with the real grid system?
Okay, yes, I can try to answer this. Basically, the governments are supporting some research projects with different kind of funding tools, of course. And I would say the direction is towards pilots and demonstrations, and this is also, if we think about the European level, this is very important now. And of course, doing this interconnected with the real grid can be challenging when we have real customers connected to the grid. But of course, we are all the time doing demonstrations, and we are also involved in many kind of demonstrations in Europe. So this is very much possible. And yeah, I think the sizable pilot, that's of course a good question. It needs to, I mean, gaining the a large enough pilot can be challenging, of course, because these demonstrations they are often quite small scale. But this happens, and we are active in that.
Okay, and so do you have any final comments for the audience before we wrap it up?
I at least hope that you get the idea of VTT's thinking and activities in this challenging field.
Okay.
I would love. Yeah, can I? Yes, I see some more questions about NAS storage system, but I'm sorry, I'm not a specialist on that. It was more from the application perspective on my slides, but I think VTT has done research on this as well, but I'm not sure if I can get any context to this system so that I could provide some reports or something. But VTT has done some research on this as well.
Yes, VTT will have all these questions that have come in, so if we haven't got time to answer them all today, VTT will have the opportunity to answer them at a later stage.
So that just leaves me to thank Dr. Araksinen, Dr. Mäki and Dr. Virtanen for what was a great presentation, and thanks to VTT for sponsoring this session. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group Business Review Webinars. Thank you once again, and I hope you all have a lovely day.